Hey, you're watching the LEGO Build and Learn series, combining SolidWorks skills with LEGO creativity. In this third lesson, we're going to save a copy of our original 2x2 plate and modify it to create the side pinholes and additional detail that can be found in that part. You also start to see some of the issues I was having with dimensioning. As we're progressing the assembly, you're starting to see that some parts weren't quite fitting together yet. Let's get started. Okay, next in the instructions. Right, two of these parts. These parts are called a 6069832 modified plate with pinhole. Let's go to our 3D. Okay, cool little detail on a... It's very similar to a standard plate, although you'll notice on the top, it's got holes where they don't normally have holes. So that is interesting. I wonder why that would be. If anyone's got any ideas on why they would remove the material from those parts, send it through the comments. I suspect that it is a cost-saving measure because typically these pinholes are used for wheels, and typically the wheels would be underneath other parts, and so the top of these is not visible. So they need to connect. They still need the outer of that circle. They don't need the material on the inside for the Lego brick look. So that's my theory. Love to hear what you think. Now, once again, it's a modified plate, isn't it? So really glad we created this part first. Let's create a new version. Now, this time, when we do save as, make sure we're doing save as a copy and open, okay? And we're going to call it full cross support underneath. I think we'll just call it plate modified 2x2 with pinhole. Save as copy and open. All right. Now, there are some changes with this design to the original, being here and here. So on the bottom, holes are different. You can see they haven't actually removed any material here for the wall thicknesses of those tops because they don't have to. So maybe that's another reason why, because it's got this support and a flat bottom. That way here that they're not having sink marks from extra wall thickness that they don't need. That could be another reason too. So we need to change quite a few things. First up, we need to change the tops and remove that material. So we're going to roll back to this stage here, and we're going to go into this boss extrude and edit this sketch, and let's check some dimensions on our new part to see if they're the same. They look the same. Yeah, 4.85, cool. And we'll measure the hole on the inside, about 3.1. Now, is that what we got last time for the stuff on the bottom? It's a different feature, but it was a 0.8 wall thickness. So how does that work out this time? If it's 3.1, what's our wall thickness going to be? Close to 0.8, so let's suggest it is 0.8. I'm going to change that dimension and move it to here. And then I'm going to draw in 3 more circles, select all of them, holding control, and make them equal. Okay. So very quick to modify that detail. The extrude height doesn't change. Now the shell changes, but you can see here, by removing that material, it doesn't shell through that wall anymore. So we get the flat bottom that we kind of needed. Now this shape goes. We're going to suppress it. We'll just leave it there in case we need to add anything later with it. This one actually comes back. So as you can see here, when we flip this upside down, there's a pin there. Now that's for connecting purposes. But the difference between the 3D CAD in this image and in reality, this part has very small pinhole. See there? So that's different again. The other feature I'll show you just while I've got the up close, there's also a step down in the hole going through and that wall that goes through the middle. So we'll put those in. So we can here unsuppress this one, but we will have to change, and it's got some missing relations. What we will do though is actually roll back, and we will do let's just get our orientation right. We're going to add the new part, I think, to the left of screen. Yep. Okay, so we're going to put the support bracket on the right side over here. We can measure the width, 1.2, 1.1, and measure the gap on the side, 4.8. All right, so that's the support rail. Now let's see what happens with this one. Yeah, it's on the wrong side. Reason is it's along this line here. That hasn't changed, but it needs to be over on this bit here. So I'm just going to add a relation to the origin and a relation to the midpoint of this recessed area. Okay. So that detail is now corrected. It's actually worth me checking just through here. You can see it's actually not in line with those ones underneath. So I think that's a measuring issue. I think this one needs to change, and I'm going to do that by changing the dimension, adding a construction line here and a construction line here, making those for construction, using this midpoint to actually measure where that should be. And this says 5.28 now. We'll just measure that again. I'm definitely getting less than that. Definitely getting less. Let's try another dimension check. Outside to the outside, 7.5. So that's from here to here. Yeah. Let's change this to 1 so that I'm getting the 7.5. Let's roll with it. Again, it's not going to make a huge difference for us. Now, is this midpoint? It should be now vertical, which it is. Okay, we're not producing these parts. So if my measurements are off by 0.1 of a millimeter, it's fine. So we're learning how to measure different geometry, but we're not learning how to measure to 0.1 of a millimeter. It's not the aim of these lessons. Okay, save that part. Now, the pinhole on the right side, cool detail. Let's do it on this face. It's flush on this face. We're going to do 2 circles. We're going to do the first circle by looking at this. You see, we should be able to measure the full diameter, the full width of that. So, go to my calipers. Then I can get a measurement of 7.8. Cool. I can also get the height, 7.8. From here to here. Is that right? No, measured from the wrong face, sorry. Dimension from the wrong face. It's from here, and it is 7.8. That gets better. You can see it's actually tangent. Cool. Make that vertical. Now there is a hole on the inside, which we can measure the inside of. We'll say 4.9. And the length of this, 7. So we're going to go extrude, lined, 7 millimeters inside. Okay. Now that's giving us the outside shape. There's a little bit of work to do on the inside shape. And for this, I'm just trying to have a look at what happens at the back here. So it looks a little bit different. Can I see the back of it? Because the plastic is gloss, sometimes it shows different reflections in the part. So it can be hard to tell if it's an actual edge you see or if it's a reflection of some other feature. But in this case, I think the hole just stops. There's a very small edge, I think. Like it's basically on that face anyway, right there. So all we're going to do on this one is use our same contour. So you'll select that boss extrude, that sketch 10. I'm going to cut extrude. We're going to go to selected contours, delete what's there, and then select the inside circle. And you see when it cuts through, I'm going to cut up to this surface, and now it clears the inside for us of that shape. Our last step is to do a little step down. So that's here, this little step down on the inside. For that, again, we can measure our diameter, 6, and the depth I'm going to guess on this one. Let's just do a new sketch, make it easy, find the center point of that, put the dimension in, pick our number, 1 millimeter, and we are done. And that's part. Let's add it to the assembly. Now there's 2 of them. Beautiful. Okay, so we're going to go back to our assembly, insert components, have 1 on that side. Yep, 1 on this side. Should we start using a mirror feature? What do you guys think? And if we see here, like step 9, we've got these 2 parts on both sides. Same on step 10. No, not step 10. Well, we've got this part here. Step 11, these. I think it's a good idea to start using a mirror feature. Okay, so what we're going to do, we're only going to add 1 of these. Keep it to this one. Add our mates. It's going to be coincident there. We're going to this face on this side, flip, and then we're trying to line up these next parts. We can just go circle on circle. No, they're not concentric. It's probably a CAD flaw that, we can't add that one, so we won't do it. Cancel. Instead, what we can do is get the right plane of that part and match it to that face. And we can see there when I do a top view how those holes are misaligned. I'd love to resolve that. And I think trying to resolve it earlier might be better than later. Okay, then here there's some misalignment. Oh, well, let's have a think about it. If it really comes back to the original plate, and our original sketch, this one, how far everything is off the edges, but it's all symmetrical. I think the issue is it's off the mid plane here, but it's not. Yeah, that's the problem. So when you flip it, just adding some more construction geometry, and you flip things around, they're not all in the right spot. To get it in the right spot, we need that 1.42 and 1.64 dimension to be exactly the same. Now there is 0.22 difference between them, which means you have to remove 0.11 from this measurement here. No, that's not it, because it's on a sliding scale. It's closer. The magic number is 7.9. So then all our gaps, 1.53, it's 1.525. It's fine. Okay, 7.9. Let's remember that. We'll save it on this one. Now let's go to our other bricks, and we'll just change that dimension. You don't have to change anything else. 7.9, and to this one, 7.9. Oh, no. Caused an error here. What's the error? The error is it's no longer in the middle. That's right. How are we going to solve that? That comes back to this one here. 2x1, and this is to do with how much we move those faces. So if we have a look at this sketch, it's 0.1 off. We don't want that. If we remove that, then it's fine. So it's this move face we delete. Okay, 8.02 for a single sized pass. I have to get a few more of these parts out. I realize that I should be assembling it at the same time. 8.02, no, it's not all that. I don't think we need to make any changes to it. Bring that down, get rid of that. That's 7.9 minutes perfect. Okay, that's better. That should be good. Let's go to this one. So delete that move face, that sketch. Good. This one, have we done already? Yep, still delete those. Okay, so we've actually cleaned things up by getting that dimension right. Now, if we go back to the assembly, let's have a look at this one again. So on this top part, let's get rid of that last dimension and see if we can now go to mate this one and this one. And they work. Awesome. Okay, that was a good way to troubleshoot. Now, our assembly step means there's 2 of those. So, mirror. We're going to create a mirror feature that we're going to keep adding parts to as we go. For now, it's just going to be one part that we're mirroring. We're going to select the right plane. We go to move component, the drop down. Sorry, it's under linear component pattern. Kind of weird, but click mirror components, click this part, click the arrow to see the next step. And now if we look at the preview and it looks good, then we don't have to go through the rest of the steps in the mirror process. We can just press OK. When we get into more complicated part design, sometimes you need to go further through the process to select different options for alignment for your mirrored components. All right, let's assemble some stuff. So step 1, step 2, step 3. Cool. All right, part 4. Let's get to that one. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe, and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.